So let's say I want to find this limit. So I want to find the limit as x goes to 1 of 2x minus 1, x plus 3. This is a limit to a point, so all I have to do in the beginning is to substitute the point in. So I get 1/4. And since I've added a value, the limit is found, the limit is 1/4. Okay? So in the graph at 1/4, there is the value of the function. It's a function of the limit. And then I might have to compute f of 0, which is minus 1/3, and f of 2, so a point before and a point afterwards. At 2, so it would be 3/5, so I know it goes like this. And that's it. Let's go now to the next one. Here, I want to find the limit as x goes to 6 of x minus 6 over x squared minus 36. Okay. Again, I do the same thing. I plug in the value. So I have 6 minus 6 over 6 squared minus 36. It will give me 0 over 0. What do I do here? I factor, simplify, recompute. So I'll have to write again limit as x goes to 6 of x minus 6 over x minus 6 times x plus 6. Here I'll have a cancellation. So this is the same as the limit as x goes to 6 or 1 over x plus 6. And then I plug in to recompute and I'll have 1 over 12. So the limit exists, but I have a hole at 6, 1, 12. So if I make the graph, here it fits. At 6, 1, 12, I have a hole, okay? And I need to find maybe f of 5 to see if it's below 112 or less, and find f of 7 to see if it's below or less, to see if it goes like this or it goes the other way. So if I plug in the number and I find the number, I'm done. If I find 0 over 0, I have to factor, simplify, recompute. I might have to multiply by the conjugate or something like that. But I have to do this step, okay? And if I come up with a number, I'm done. Let's look now at the next problem. Here I want to do that limit that you see or don't see up there. So I want to do the limit as x goes to 1, but from the right, of square root of x minus 1 over x minus 1. Again, I plug in, so I have square root of 1 minus 1 over 1 minus 1. So I have 0 over 0. Again, what do? I factor, simplify, and recompute. In this case, because I have a square root, I'll need to write again the limit as x goes to 1 plus of the expression. But I need to multiply in this case with a root again. And then I'll get the limit as x goes to 1 plus. The two roots cancel each other out. On the bottom I had an x minus 1 and I have now the root. This cancel, so I have the limit as x goes to 1 plus, or 1 over square root of x minus 1. Then I substitute back in, so I get 1 over square root of 1 minus 1, which is 1 over 0. So what's the conclusion here? Not a hole, but a vertical asymptote at x equals 1. And because I'm doing only the limit from the left, I'll have to study on the side limit as x goes to 1, from the right, of f of x. I know this is going to be infinity, I just need the sign, so I take a point on the right, which is 1.1, and I check the sign. It's going to be plus, over plus, so plus infinity. Okay. So plus infinity. And then if I am to make the graph, I'll have at 1, okay, I have a vertical asymptote, and I approach it this way to plus infinity. Let's look at another one. So here I have a piecewise, and I want to study the limit as x goes to 2 from the left of the function. So if it's from the left, okay, you can see the function, okay? From the left, that means for x less than 2, so I take this function. So this is the limit as x goes to 2 from the left of x plus 5. Again, I substitute first a number in, so 2 plus 5 is 7, and the limit exists. Okay, so if I make the graph at 2, 1, 2, 3, 4, 5, 6, 7, I have a hole over here. The function is a straight line with a positive slope, so it goes like this. Okay, but because I don't have the equal symbol, I put a circle. And I should do at 2 what happens. At 2 I take the other function, the x squared. F of 2 is 2 squared is 4. So 7, 6, 5, 4. I have a hole here. And this is the graph, the limit. So in piecewise, we're careful, if it's a side limit, which part to use. Let's look at the continuity also. So in continuity, you have to remember to use the definition, okay? You have to remember to use the definition, and here we're looking at a equals 4. So first I have to check f of 4, and by the piecewise it's equal to 3. Then I have to find the limit as x goes to 4, and if I substitute on this function, because the limit means approaching from the left and right, x squared minus 2x minus 8 over x minus 4, I will get 0 over 0. So I will have to play the same game. Factor, simplify, recompute. So I write limit as x goes to 4, and I factor. I have an x minus 4 for sure on the top, and I have an x plus 2 over an x minus 4. These cancel. So I have the limit as x goes to 4 of x plus 2. And then limit to a point, I substitute again, so I have 6. So the value of the function exists, the limit exists, so my third condition, does f of 4 equal to the limit as x goes to 4 of x plus 2? And of course the answer is false, as 3 is not equal to 6. So this continues at x equals 4 as it fails condition